Assalamualaikum and hi everyone. My name is Noina Batrisha binti Zulkarnain with metric number 2010792 with Z Alisa Inshira and Nadira Nazrin. Our group will be presenting about the late 20th of advanced polymers and composite. Please enjoy and watch. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to talk about the development of Kevlar. So it develops in the mid 1960s by the chemist Stephanie Qualek at DuPont. It was originally to make lightweight fibers for tires. Its properties have high strength, high durability, and high heat resistance. So due to its molecular structure, the long chains form a strong hydrogen bond, which explains the high strength. It is also suitable for protective and industrial uses, and due to its heat resistance, it is perfect for the usage of a bulletproof vest. Now, moving on to applications. Kevlar is mostly used in bulletproof vests, but it is also used in helmets, tires, ropes, and other reinforcement materials. Its high strength to weight ratio and heat resistant make it suitable for protective and industrial applications.
Next, I'll be explaining about the development of polycarbonates. Independent discoveries of polycarbonates in 1953, two scientists, Hermann Schnell at Bari in Germany and Daniel Fox at General Electric in US, independently synthesized polycarbonate as they recognized the properties of polycarbonate. First, high impact in resistance as it could withstand strong impacts without breaking. Secondly, heat resistant. Polycarbonate could endure high temperature. Third one, optical clarity, as it was transparent, making it ideal for lenses and windows. We will continue with the manufacturing process of polycarbonates. First, monomer production of BPA and phosgene. BPA of bisphenol A synthesized from phenol and acetone. Phosgene, a toxic gas used as a reactant. Second, the polymerization. Interfacial polymerization of BPA and phosgene will react. Polymer chain formation of BPA and phosgene as the reaction forms long chains of polycarbonate molecules. Next is the impact of polycarbonate. First, it can use as everyday items in CDs, DVD, and eyeglasses. Second, in safety gear, helmets and safety shields. Third one is automotive parts like headlights and car interiors. And the fourth one is electronics like phone cases and computer components.
Assalamualaikum. Now, I will present about the development of polyurethanes. So the first one, which is the early discoveries, which is found in 1930s. Polyurethanes were first made in 1937 by a scientist named Otto Bayer. He found that mixing certain chemicals, which is diisocyanates and polyols, it could create a new type of material, which is polyurethanes. And then, after that discovery, it was used in the war efforts. During World War II, polyurethanes were used to make lightweight cushion foams for military equipment like helmets and seat cushions. Moving on, the applications of polyurethanes started to expand. Polyurethanes became available for everyday items such as mattresses and furniture. This is thanks to their comfort and durability. People also started using polyurethanes for coatings, adhesives, and sealants because they stick well and are flexible. They also found their way into cars and industrial products. Next, these are some of the properties recognized in polyurethanes. Firstly, they are resistant to abrasion and wear, making them suitable for high traffic areas and heavy use. Second, polyurethanes can be flexible or rigid, depending on their formulation, allowing them to be used in a wide range of applications. Third, they are also lightweight. This is because of their low density, which makes them easy to handle. Last but not least, they have strong bonding capabilities, making them useful for adhesives in construction and manufacturing. Polyurethane is a plastic material which exists in various forms. It can be tailored to be either rigid or flexible. So, these are today's examples of polyurethanes. The first one, it can be used as a building insulation. The rigid polyurethane foam are used in walls, roofs, and refrigeration. The second one, it can also be used as a protective coatings, such as paint and varnishes for wood, metal, and concrete surfaces, providing durability and weather resistance. And then the third one, it can also be used in automotive applications, which is the foam cushions for car seats. And then the last one, it can be used in performance fabrics, which is used in sportswear and outdoor gear for waterproofing and breathability.
Now I will introduce to you to biocompatible polymers. Biocompatible polymers are actually designed to interact safely and be completely harmless to the human body. Their physical, chemical, and biological properties are tailored towards to meet the specific needs of the human body. It must be non-toxic, non-inflammatory, and degrade into body-compatible substances. These polymers are widely used in the medical field. Now we learn about the manufacturing process of biocompatible polymers, which involves a combination of chemical reactions, purifications, and modifications that ensure the final material meets the necessary standards for medical applications. So, in the application of polymer, it is mostly used in the medical field, which includes medical implants, drug delivery systems, and tissue engineering. For example, PLA, polyactic acid in biodegradable sutures, and also PEG in drug delivery.
Introduction of biodegradable plastics. What are biodegradable plastics? They are a type of plastic that can be broken down by microorganisms into simpler substances like water and carbon dioxide. This means they can decompose naturally, unlike traditional plastic, which can take about 100 years of to break down. How are they made? This plastic can be made from various types of sources, including plant-based materials like cornstarch or sugarcane, and microorganisms. Some bacteria can be produce biodegradable plastic. Why are they important? First, it can reduce pollution as they can decompose faster, reduce plastic waste. Second one, eco-friendly because they are made from renewable resources. The third one is sustainable future. They help us move toward a more sustainable way of living.
In conclusion, the development of materials like Kevlar, polycarbonates, and polyurethanes showcases the progress in polymer science, leading to their use in many industries. The rise of biocompatible and biodegradable polymers reflects the growing focus on sustainability and environmental care. These advancements highlight the balance between performance and responsibility, pointing to a future where polymers are both effective and eco friendly. That's all from us. Thanks for watching.